All right, so let's take a look at run levels, targets, services, and processes. I'm going to fly through this Notepacket since this is the second time I've done it. So anyway, let's get right to it. What is a process? It's just a program that's running on your computer. It can be running in the foreground or in the background. So for instance, this web browser is a program, it's a process, and it's running in the foreground. I can see it, I can interact with it. Daemons, on the other hand, are processes that run in the background. They kind of sit there and they hang out for long periods of time until they have a task to do. They do it and then they go back into the background. A service is a program or a set of programs usually running in the background that performs a specific set of system functions. For instance, let me go right forward here. These are some examples of some well-known services. cron, and particularly cron D, the D stands for daemon, that's the scheduler. Apache Web Server, HTTPD. We'll look at that in a bit. CUPS, Network Manager. CUPS is the printing system, networking, email, and all of these are services. All of these are processes or programs that get set up to provide a service either to your computer or to the internet or the network at large. So Samba allows Windows computers to connect with Linux computers and vice versa. SSHD, well, we know what that is. That is the secure shell daemon. So this is just a very small subset of the possible services that can be provided by your computer, by your Linux server, and we can start and stop and enable and disable each of these services in turn. Let me back up for a little bit because there's one other topic that I'm just going to touch upon. It's the concept of a run level or a target. That's the mode in which Linux is currently operating. There are three basic run levels, and then a couple others I'll throw at you. There's the graphical target, which is the GUI. When you boot up your machine, the computer typically defaults, or Linux typically defaults to GUI mode. But it's possible to set it up so that it's a non-GUI mode, just a text-based screen. And then there's this third option, which is a rescue environment. You know, if something gets misconfigured or some hardware goes kablooey, your system might not boot, and Linux, Red Hat in particular, and its variants will try to dump you into a rescue environment for you to fix the problem so that the system will boot later on. So those are the basic targets: graphical, multi-user, and rescue. And in the older jargon, those were called run levels 5, 3, and 1. It's handy to know about them just in the sense that sometimes you want to break out of run level 5 to get into an emergency mode real quick. So there are others also. Run level 0 is power off mode, shutting down the system. And when you boot into run level 6, you're going into a reboot. So I have a CentOS virtual machine up and running. And for those of you who are working in 360 or maybe even in the classroom system, I set up a CentOS virtual machine for everybody, and you can access it right through Guacamole, right there. You click this tab, you'll see your machines, and you can get into your CentOS. Oh, by the way, your system may crash from time to time. I'm putting a lot of strain on CSN Linux to do this. So if your system goes kapow and it just blows up or it stops working, I have a new link inside the course. It's Reset Your Guac. You click that link. This menu comes up with only your machines. You click it, click whatever machine you want to reset. You click Submit, and wait about a minute, and your system should reboot fully. So again, if your system goes foul, try that, and it should reboot your system. And if that fails, contact me, and I can reset it for you. All right, so anyway, back to CentOS. So I'm going to become root. In order to do anything at the system level, we want to become root. Again, sudo space su space dash or sudo -i. And right now we are in run level 5. There's a run level command, and it shows you that you're in 5 right now. This N means we have never been in any other run level than 5. But let me show you how easy it is to switch run levels. I'm going to type in init 3. That will bring me to run level 3. Most of my servers in the server room run by default. At boot time, they boot into run level 3 because I prefer not to run a GUI, because I think that that's just an added risk for security for a server. Different people might disagree, but that's just how I roll. Anyway, you can still log in. So I'm going to log in as the CentOS user. And the GUI might be installed. And in fact, on this system, we know that there's a GUI installed because we just saw it. So if you're in run level 3 and you want to start your GUI without entering run level 5, you have an option that's called startx. And if you type in startx, single word, lowercase, and wait a couple of seconds, and a GUI is installed on the system, it will eventually boot into the GUI and you get the same familiar desktop. You log out. So you've done your work. Now you go and you log out. When you log out, you will boot right back to where you were when you issued the startx command, which is at the CentOS shell. So there you go. Run level 3, which is non-GUI mode, but it offers the option of a GUI provided you have the software installed. All right, let me become root again. And my habit is sudo su-. You probably do sudo -i. All right, let's show you what run level 1 looks like. Not much. It's just it's an emergency shell. This is what you would see perhaps if your system can't boot for some reason. It'll dump you into this shell. You have to know the root password, which in this case is CentOS. But obviously, if you're running your own system, you want to have a pretty hard to guess, but memorable root password. And so now I'm root and I can do all my emergency blah, 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 use the VI editor, change some configuration files, and reboot the system. While we're talking about rebooting the system, remember that that was run level 6, so I should be able to do an init 6, and you see the system's rebooting. So run levels, it's a bit of a curiosity because for most of us, we go into run level 5, the graphical target, and we're just going to stay there probably for 99.9% of the time, and the other 0.1% of the time we're solving problems in single user mode. So typically the other modes are transparent to us and we don't really use them, but they're there. 2 and 4, by the way, are typically unused, and Ubuntu does follow this same run level target numeric mode, with one exception. I don't believe Ubuntu by default offers a text console mode in its typical install. You can try that, but I don't think it does. All right, so let's move on at this point, and let's talk about systemd, because systemd is what controls all of these run levels and processes and services and all that down the line. It's the first process that gets run when Linux boots up. It stays running until shutdown, and everything originates from systemd. By the way, systemd has a process ID of 1. Let's get into our CentOS machine again. Log in, get a shell, and let's take a look at the process list on our system. In fact, what you should probably do now at this point is, when you fire up your terminal, maybe also get a putty shell going separately, and get a couple of shells for CSN Linux on the side. So maybe that's what I'll do right now. I'm at CSN Linux. All right, so I just fired up my shell, and I'm going to do a PS, which is a process listing, PS. If you just do PS with no arguments, it shows you your current shell and any commands that are being run in it. Well, I just typed the PS command, so that shows up, and bash is the command that's running this window. So 2 processes. To see all the processes on the system, it's PS space AUX. A for all, U for include showing the users, and X, show me some extra information. And PS AUX shows a whole host of services and processes being run. And let me break this down for you. I'm going to scroll up to the top. On the left-hand column is the user who's running the process. Then the process number or the process ID, CPU and memory usage, and then a whole bunch of other stuff when it was started. So this system was last booted on October 15th. And since then, this particular command, there's systemd, has been running. So systemd is process ID 1. It's the first process to run at boot time, and everything spawns from that. If process ID 1 dies, your system's toast, and you're going to need to restart it. All right, so everything spawns from that, and so eventually you'll start to see other users other than root. So KJ Mead is running this evolution address book on process ID 416 and on down the line. All right, so you see there's a whole bunch of them. If you want to see how many processes are running, pipe it to new NL. Right now on this system there are what appears to be 499 processes, and I bet you if I run it again, there'll be a different number. No, I guessed wrong. Oh, there we go, 504. So processes pop into existence and then go away depending on the needs of the system. So back to our services. So we understand what a process is. It's just a single running program. And then there's services. Services are, they provide a service either to the computer itself or to the network at large. Like a web server is meant for other people to connect to your machine to grab web pages. But cron, well, that's a scheduler on that machine. So again, but the common thread is that they provide some sort of a service to us. And that, I'm overusing the word service, but you understand what a service is. Like you go into a restaurant, you expect to be served dinner. So that's what a restaurant does. But they can also serve drinks. They can do other things. So probably not much other things, but you get the point. So we're going to talk about services, and in particular, we're going to talk about starting and stopping services. Now I'm going to pause the video here. I just want to make sure something is in place, and I'll come back in a second. Okay, I'm back. So starting and stopping services. So we're going to make the basic assumption that we have a service on our system called HTTPD, which is the way that we, or the term for the Apache web server, at least on Red Hat-based systems. Now that's actually a bad assumption because I don't think we have Apache installed. How can we check that? Well, remember from the last lesson, we can do an RPM -Q, and it shows that it's actually not installed. So let's install it now. Remember, yum install HTTPD will install the Apache web server, and I wouldn't expect that you know that, so but now you do. What happened here was it found a whole bunch of dependencies, well actually only 3. It's going to download them and install. So while that's working, so that's chugging away installing the server, let me talk about the service command. So assuming we have the HTTPD software installed, that sets up a service in the in systemd, and we can start, stop, restart, and get the status of any given service that's installed on our system. I think we're probably ready here. Oh, still going. Okay, so let me show you these examples. The first thing we're going to do is I'm going to do service HTTPD status. And this will give me the current status of this particular service. It recognized that HTTPD is the Apache web server, but it's not running right now. So you'll see this active : inactive. It's dead. It's not running. And furthermore, it's disabled. All right. So 2 things at work, and I'll describe what both of those things mean in a second. But the most important thing right now is that it's not active. It's dead. The way that we activate a service is we start it. So service start HTTPD. Sorry, that's backwards. Service and then the name of the service and then start. And it takes a couple of seconds, but essentially what happened was a whole bunch of processes started up in the background. I'll show you that in a second, but for right now, let's rerun the status command, service HTTPD status. Let me clear that out and start from scratch. So you see now it is running, active running, and it's been running since, well, about 20 seconds ago. However, it is still disabled. So what do we mean by disabled? Well, it simply means that the next time the computer boots, Apache's not going to start up by default. So it can be running now, but the next time we reboot, it's not going to be automatically running. So we're going to see how to enable a service in a second. So to prove to you that a bunch of stuff happened behind the scenes, let me clear this out again, show you a PSAUX, and then I'm going to grep HTTPD. And in fact, 1, 2, 3, 4, 5, 6 different versions of Apache, or 6 different processes were actually fired up. So it's different than just starting a program. Starting a service can start multiple things, and they all start in the background, and they're all kind of handled by this systemd thing that I'm referring to. So that's in charge. Systemd is in charge of keeping track of which services are running, starting up, shutting down, etc., etc. We can always restart a service by typing in service, then the name of the service, and restart. And if it's stopped, it will obviously restart it. It'll start it up. And again, we'll do the status thing, and it's also active and running, and it's been running since, well, 10 seconds ago, and you get the point. And so we can start, we can stop, and we can get the status. Actually, so we know that it's running. So let's prove that. I want to just demonstrate this to you. On your system, you do have Firefox, and the a web server provides a service so that we can read from a website. And our website, since it's on the current or local machine, we can access this by typing in localhost. And if you see this testing 1, 2, 3, it means your web server is running. I'm going to prove this to you. Remember the other command that for service is we can stop a service. Service HTTPD stop shuts it down. I'll prove it. See, it's inactive, it's dead. And we'll prove it, double prove it by bringing that web page up. I'm going to hit refresh, and notice it says unable to connect. So Apache, we just started, stopped it, restarted, got its status. So you should definitely know these 4 commands for any given service. Let me show you one other service that is enabled by default. That's the SSHD service. Oops. So let me get back to that tab. It's this one right here. And I'm going to clear out. So let's do service SSHD status. So SSHD is the SSH server, and everybody's virtual machine, you can actually SSH into it if you wished. It's active and running, and notice it's enabled, which means that at boot time, SSH is set up to automatically start up when the system boots. All right, so it's running and it is enabled. Now, if we really wanted to, we could shut the service off. That's if we were afraid that somebody else might try to SSH into our system. So now it's inactive, but of course, might as well just start it, and it's now started up. So SSHD is an example of another service. There's all those other ones that I mentioned on that one slide. We have the option of starting, stopping, and reloading, etc., etc. And you'll do a little bit of this on your tutorial for this unit. All right, so that's the status or the service command. Now, we talked about enabled services. Those are services that if we enable a service, it will start at boot time. Technically, it starts when we enter that run level or target, but for all intents and purposes, it's when we boot the system, will this service start or not? Well, to do that, we actually have to learn a new command, and it's system control. And I want to tell you something about system control. When we issued these 4 commands, we were actually running the service control, the system's CTL command. So an alternative to service start, service HTTPD start, we could instead have entered system control start HTTPD. This is the same as this. These 3 are the same as these service commands, but using system control. So you don't have to remember 2 sets of commands. You could get away with just memorizing this one. Now there's 2 additional useful. Actually, system control is a very rich. There's tons of sub options in it, And the only ones that I really, really need you to know are how to enable and disable a service. So let's just take a look at it. As I mentioned, one more time, HTTPD status, we'll see that it is disabled by default. If we want to enable it, it's system control, enable HTTPD. What that does is it creates a symbolic link. It gives you some information. But long story short, you don't have to know the nuts and bolts of that. You see now that this HTTPD service is enabled. So the next time we were to boot up the system, the web server would automatically start. Okay, even though it's not running right now, it will start the next time we start the system. Right? So know about enabled services, and likewise we can disable it. Same set of commands. So instead of enabling it, I will go back in and disable it. Why would you want to disable a service? Well, the fewer services you have running on your system, the less chance that there's a security flaw that can be exploited by the bad guys. So, rule of thumb, you want to run as few services and as few programs on your server, especially if it's exposed to the internet, as possible. So my first job as a sysadmin is I go in and I shut down any services that are absolutely not necessary. So I would disable them and I would turn them off. Okay, so enable and disable. And then you could, if you really wanted to, get a list of all of the services on your system by issuing this command. But I got a little secret. I can't ever remember this command, so I just go and I Google it whenever I need it. All right, so we know about services. Let's finally talk about processes. So we've talked about systemd, and we've seen some other processes, and we also know how to do a process list. So let's go and do some things with processes. And I want to show you how to interact with processes. And there's some things that are not on these slides that I want you to be familiar with. Okay, so I have two shells set up on CSN Linux. Once they're side by side. And let me clear this out. And we'll do a PSAUX. And I'm just going to grep myself. Take a look at all of the processes that KJ Mead is running. And there's an awful lot there. I've been busy. So we've used this command in the past, and it's useful for these purposes. But remember the sleep command and something like sleep 20. So if I issue the command sleep 20, notice the purpose of the sleep is it basically pauses your shell for 20 seconds. But further notice that I don't have my shell. I can't do any other work in here. Sleep is running in the foreground. So I'm going to crash it right now. Control C to crash a program that's currently running. And I'm going to issue sleep 20 to run in the background. And the way that we do that is we put an additional ampersand at the end of the command. So I'm going to do that. I'm going to press enter. And notice I have my shell back. But if I do a PSAUX and I grep sleep, here's my sleep 20. And it's sitting around and it's working in the background. So I have access to my shell. I can issue commands. And guess what? In 20 seconds or so, probably about 5 seconds from now, sleep 20 will be over. See, it's gone. And notice we got this little done sleep 20 because the command was finished processing, doing stuff. And so it gave me this nice little message that it was finished. All right, so what I'm going to do now is I'm going to issue a bunch of sleep commands. I'm going to do sleep 300 to give myself 5 minutes of sleep. And I'm also going to put it in the background. And in fact, I'm going to put a bunch of them in the background. I'll do one more. Okay, so if I do a process list, now I see a whole bunch of sleep 300s in the background. Now, one way to get rid of a process is to do Control C or to let it just finish its job. But sometimes you need a process to end prematurely. And you don't have access to it because it's running in the background. Not a problem. Let's say I want to kill this particular command. Well, what I need to do is I look up the process ID, which is 30311. And it's just on this, I mean, yours are going to be completely different, but you should definitely play around with this. And I'm going to kill it. Kill 30311. Press enter. Boom, it was terminated. And if I do this process list again, we're going to see that there is no more 30. What was it? 30311. Okay, there's a 30300, a 30313. All right, so I can just kill each of these in turn if I want. All right, that one's gone, or at least it should be. Yes, all right? Yeah, 30313 is gone. So the nice way to kill a process is, I mean, it sounds real nasty, like you're killing it, but in fact, this is a nice, gentle way to stop a process. This is the equivalent of going over to the process and saying, hey, you know what, Sleep 300, I'm good. I'm done with you. I don't need you to do any more work, so I'm going to kill you. So what you should do is just go and clean up all your files and let everybody else around you know that you're going to die, and then you can die. So it's a very nice, gentle way. It gives it some time to clean up its affairs, if you will. So I'm going to do that one more time with the 30300, and it seems like it happened fast, but a few things happen in the background. However, sometimes things don't want to go to sleep, and things don't want to be killed. It's in that situation where you need a stronger course of action, and that would be a kill -9. So that's on. So that's this slide right here and this slide right here. Kill -9, you want to try to avoid it if possible, but sometimes a program does not want to die. Let me show you an example. I'm going to go into my other shell here. I'm going to do a PSAUX, and I'm going to grep kjmead, and I'm going to grep bash. So let's see. How can I tell which? So I'm running bash right here in this window, but I'm also running bash in this window. So which one is which? Well, I can do a PS on this one, and remember back a couple of minutes ago, this tells me which bash I'm in. So 22371. So it must be. I'm guessing it's this one here. That's the other shell. So I'm going to try and kill it. Remember, to kill something, you just enter kill and the process ID, and you press enter, and let's see if it worked. So I'm going to do a PS, and lo and behold, it didn't die. It didn't want to get killed. So if you really need to kill it, that's when you use the more harsh kill -9. Kill -9 is the equivalent of, I'm just going to go up, sneak up on that process and stab it in the back. All right, it has no chance to clean up its affairs, call its mom, blah, blah, blah. It's just dead. So now I kill -9'd it, and notice my connection to CSN Linux is no more. So if you want to try to kill gently with just a kill command, but if it doesn't work, kill -9. Okay, one more thing. Actually, a couple more things. Let me show you the top command. Actually, no, I'm gonna fast forward to the final thoughts, and then I'll come back to top. Final thoughts. Let me go reissue the sleep 300 command again a bunch of times. That's a lot of times. That's a lot of sleeping. Okay, good. PSAUX grep sleep, and boom, we got a whole bunch of them. A whole bunch of sleepers owned by kjmead. So sometimes you just want to get rid of a whole bunch of processes at the same time, and provided they all have the same name, you can do it in one fell swoop, and that's by using the kill all and then the name of the process. So kill all Firefox would kill all the Firefox processes. In this case, ooh, I don't know what just happened. Oh, that's right, I'm in CSN Linux here. In this case, I'm going to kill all sleep. And this will kill all the sleep processes, or all the processes named sleep that I own. All right, I can't kill roots, obviously, and I can't kill one of your sleep processes, but I can kill all of mine, and boom, 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 a bunch of them are terminated, with one exception. It didn't want to kill the root process. And notice if I do a PS, it also, if I grep, it will grep the grep. Don't worry about that. So all of these sleeps were killed. So again, to summarize, kill by process ID, and you can look up the process ID by using the PSAUX command. You can kill -9 if it doesn't want to die. You can kill all by name. You can kill all -9. Finally, there's one last command I want to mention to you. It's the top command. It's an extremely useful command. Let's say your system is slow. It's sluggish. Something doesn't seem right. Well, it could be that you have an out-of-control process, something that's hogging system resources. Well, I have a command that I created. It's called bad process. And I'm going to run that in the background. In fact, I'm going to run it a couple of times in the background. And bad process is exactly that. It's a process that's set up to use a lot of system resources. Well, so let's say my system is sluggish. A way to see a process list and all of the processes that are using that the CPU will be listed in order of highest CPU usage down to lowest. And notice that there's this bad process is at the top of the list. It's using 100% of the CPU. That really sounds bad until you realize I'm going to just hit a 1 in top. I have 12 CPUs. So it's using 100% of this first one and 100% of the 10th one, but the other ones still have plenty of headroom to serve up the system. However, if I had run this bad process 12, 15 times, we might start to be in trouble. Anyway, so you can identify your so-called bad processes, and then you can kill them either by process ID, or since they're both the same name, I'm going to kill them by name. So I'm going to kill all bad process. And there we go. They're both terminated. I type in top again, and system's back to normal. Although that KVM looks like it's using a lot. Those are all the virtual machines that I have set up, so they are going to use a lot of CPU and memory. Okay, well, I think we've done it. I don't think I missed anything in here, and I'm not sure how much time was used, but hopefully you did. You got a pretty good snapshot of the nuts and bolts of Notepacket 15. All right, well, hopefully this helps, and we will see you next time.